So, in the previous days, we've been kind of looking at some of these properties of logs, and we're going to keep going with these properties of logs. I'm really going to focus on these over here for this second piece. So many of your things will say like write as one log. So I'm going to use this over here. Oopsies, I need my pen. That says if I'm adding logs and they have the same base, I multiply the numbers together. So these have the same base. So to write as one log, I'm going to use that base, and then I multiply these two together here. When it's subtract, I'm going to use this. Sorry, I had to pause my video for a second, so if I repeat myself. When you subtract, hopefully that you see that over here, then we can just combine them into one to divide them. So this will be log base 3 of 18 divided by 6, and since you can simplify that, I want you to do that, log base 3 of 3. Okay, so writing as one log means combining them. This specific one uses a different property that's back on our last sheet that tells us if there is an exponent, we can bring it down to the front. And this is one of the most important ones that we have about this exponent. So I can rewrite it as x times log base 2 of 8. And I'm going to rewrite this as 2. I'm going to just use y so that I can figure out what that is. 2 to the what equals 8? Well, that's 3. So over here now I have x times 3, and we would never say that. We would just say 3x. Okay, so the log base 2 of 8 to the x, we can just rewrite as 3x. Next property we have says that if you have something on the left and something on the right that have the same bases, that means these things are the same. And it only works, of course, if they have the same base. So now this was pretty easy. You're just going to set it up and solve. And this is just a algebra equation that you should be able to solve. 3x plus 2. And subtract 3x. And easy enough, x equals 1. So those are pretty easy. I'm going to show you one that's a little bit more difficult next. So these all have the same base, but this is going to be kind of a multi-step thing. So first I'm going to take care of this. Since I'm adding them, I know that I can combine them into one log where I multiply these two pieces. So I have log base 11 of x times x plus 1, and it will equal log base 11 of 6 still. Since these two are still equal, I know that what's on this side equals what's on this side. So now I have x times x plus 1 equals 6. So that was my first step, was combining. And then my second step was to set them equal because they have the same base. So this is x squared plus x equals 6. And then I'm going to do this because I know that I can solve this by factoring or quadratic formula. Okay. So when I solve, I get x plus 3 for factor, and x equals negative 3, and x equals 2. Hopefully you remember back to the graphing again, because one of these answers doesn't work. When we talked about y equals, let's say, 2 to the x, the domain was all real numbers, and the range was positive numbers. And then when I go over here and graph the inverse, I'm going to have log base 2 of x equals y. And remember, my domain and range switch. So the domain for this one is all real numbers greater than 0, and the range is all real numbers. What that means, though, is when I'm thinking about this, I can only put in positive numbers. So this answer over here won't work. The only answer that works is x equals 2.